Users reported successful payments but never received confirmation emails. The payment service logs showed the DB transaction committed, but the message queue had no corresponding event. The root cause? A thread pool exhaustion caused the send to fail silently, and the event was never retried. Here's exactly why. Let's start with the basics. Welcome to TheCodeForge. Before we dig into that production issue, let's cover Transactional Outbox pattern. The Transactional Outbox pattern ensures reliable message delivery by writing events to a database table within the same transaction as the business operation. Then a separate process publishes them to the message broker. This prevents data loss when the broker is unavailable or the service crashes after the DB commit, but before the message is sent. The naive approach works 99.9% of the time, but that 0.1%, that's your 3 a.m. call. The service crashes between commit and publish, or the broker is briefly unavailable, or the network times out. The DB says the order is placed, but the rest of the system never knows. This code saves the order to the database, then tries to publish a message. If the publish fails, the exception is caught and logged, but the event is lost forever. The order is saved, but no one knows about it. The fix is brutally simple. Write the event to a database table in the same transaction as your business operation. If the transaction commits, the event is persisted. If it rolls back, the event disappears with the business data. A separate process, the publisher, reads the outbox table and sends events to the broker. The first method places an order and saves an outbox event in the same transaction. The second method is a scheduled task that polls for unpublished events, publishes them, and marks them as published. If publishing fails, the event remains unpublished and will be retried. The simplest publisher polls the outbox table every n milliseconds. This works fine for most systems, but has two drawbacks. Polling adds latency proportional to the poll interval, and it puts load on the database. Change data capture, CDC, is the alternative. Tools like Debugging read the database's transaction log and stream changes to Kafka. This gives you sub-millisecond latency and zero load on the application table. This polling publisher processes up to 500 events every 500 ms. Failed events are not marked as published, so they will be retried on the next cycle. Batch saving reduces database round trips. Even with the outbox pattern, duplicates can happen. The publisher might crash after publishing, but before marking the event as published. On restart, it republishes the same event. The fix is Idempotent Consumers. Each event carries a unique ID. The consumer stores processed event IDs in a deduplication table or ready set. Before processing an event, it checks if the ID was already processed. This consumer checks if the event ID is already in the ready set. If it is, it skips processing. Otherwise, it processes the event and adds the ID to the set with a 24-hour TTL to prevent unbounded growth. The outbox pattern adds complexity. Don't use it if you don't need it. If your broker supports exactly once semantics, or your system can tolerate occasional message loss, or you're building a prototype, keep it simple. My rule: if losing a single message costs you money or reputation, use the outbox pattern. Otherwise, skip it. This is the same issue we highlighted at the start. Here's exactly why that happened. The payment service sent the message directly after the DB commit, but a thread pool exhaustion caused the send to fail silently. The exception was caught and logged, but the event was never retried. The order was saved, but the rest of the system never knew. The fix was to move to the Transactional Outbox pattern. Write the event to an outbox table in the same DB transaction. A scheduled task polls the outbox every 100 ms and publishes events. We added a unique constraint on evented to prevent duplicates. Now, even if the publisher crashes, the event is still in the outbox and will be picked up on restart. If the publisher falls behind, the outbox table grows unbounded. This slows down your business transactions because every write also inserts into the outbox. Fix: add a TTL or archive processed events to a separate table, or use a partition table and drop old partitions. If the message broker is slow, the publishers poll loop blocks and events pile up. Fix: Use a bounded queue in the publisher and drop events if the queue is full, with a dead letter queue for retries. Forgetting to index the outbox table on published created at. Without this index, the publisher's select query does a full table scan, which kills performance as the table grows. Always add a composite index. Create index IGS outbox unpublished on outbox events, published created at, where published equals false. This publisher uses a bounded queue to handle backpressure. If the queue is full, events go to a dead letter table for manual inspection. Workers process events concurrently, and failed events are retried or sent to the dead letter queue. The article mentions deadlocks with select for update. Use a version column and optimistic locking to avoid blocking business transactions. The publisher updates only if the version matches, reducing contention. When using change data capture, CDC, like Debugging, schema changes to the outbox table, e.g., adding a column can break the CDC connector. Plan for schema evolution by using a schema registry or ensuring backward-compatible changes. The article recommends indexing published created at. A partial index, where published false, is even more efficient because it only indexes unpublished rows, reducing index size and write overhead. When events aren't being published, first check the publisher logs for connection errors. Then verify the message broker is healthy. Check the outbox table for unpublished events. If the publisher is stuck, restart it. Also check the poll interval and thread pool configuration. Let's run through some common interview questions. How does Outbox handle concurrent writes? Each instance writes in its own transaction. Publisher uses select for update skip locked. When choose Outbox over XA, Outbox avoids XA performance penalty. Use XA only for atomicity across heterogeneous resources. What if publisher crashes after marking published? Event may be lost. Mark only after broker ACK. Use Idempotent Consumers. And a few frequently asked questions. What is the transactional outbox pattern? Pattern that ensures reliable message delivery by writing events to a DB table in the same transaction. How does Outbox differ from Saga? Outbox ensures reliable messaging from one service. Saga coordinates multiple services with compensating actions. How to implement in Spring Boot? Add Outbox event entity, save in at transactional service, create at scheduled publisher. Let's recap. The transactional outbox pattern guarantees message delivery by persisting events in the same DB transaction as the business operation. Never trust a network call after a commit. Duplicates are inevitable due to publisher crashes and retries, so use a deduplication store. Index your outbox table on published, created at, with a partial index for unpublished events. And remember, the outbox pattern is overkill for systems that can tolerate occasional message loss. Save complexity for when losing a message costs you money or reputation. Ready to go deeper? Up next, cache eviction policies, then distributed caching, then multi-level caching. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.